students, welcome to the session 2 of the chapter Haloalkanes and Haloarenes. In the previous session, we have seen the introduction and classification of haloalkanes and haloarenes. Today in this session, we are going to see a very important topic, which is the IUPAC nomenclature and isomerism of haloalkanes and haloarenes. Okay, you people have already studied IUPAC nomenclature in your grade 11, but we will give a quick recap of the IUPAC nomenclature regarding how much is required to name the compounds in haloalkanes and haloarenes. Like that, in which chapter we try to name the compounds, there we'll see the respective IUPAC rules for those compounds, because it is very important for you to identify the compounds in the exam and to name the compounds in the exam, or else it's very difficult to solve the questions. Okay, so without wasting any time, let us quickly start, okay, how to understand the IUPAC nomenclature of haloalkanes and haloarenes. Before that, let us write the basic format of the IUPAC nomenclature to name any compound. How do you do it? Secondary prefix plus primary prefix plus word root plus primary suffix plus secondary suffix. So this is the basic structure to write any IUPAC nomenclature. Secondary prefix plus primary prefix plus word root plus primary suffix plus secondary suffix. In this, what should be the primary secondary prefix? Secondary prefix should be your substituent. Okay, what should be the primary prefix? Primary prefix is not mandatory for all the compounds. If the compound is cyclic compound, then you will add the primary prefix as cyclo. What does the word root tell us? Word root tells us about the number of carbon atoms present in the compound. Primary suffix will give us the information whether the compound has a single bond. If it is a single bond, okay, we write "ane". If it is a double bond, we write "ene", and if it is a triple bond, we write it as "ine". And what is the secondary suffix? What do we take under secondary suffix? Very important part. Secondary suffix is your functional group. So this is the basic structure to write the IUPAC nomenclature of any organic compound. Okay, secondary prefix being your substituent, primary prefix not always compulsory. If it is a cyclic compound, you will write it as cyclo. Then the word root, which tells you about the number of carbon atoms. Then your primary suffix, which tells whether it has a single bond, double bond or triple bond, which will be ending with "ane", "ene" or "ine". And then comes your functional group. Okay, now in this chapter we are discussing about our haloalkanes and haloarenes. Now when we come to the halogen part, okay, when we come to the halogen part, okay, because naming halogen part is mandatory for all the compounds which we are going to do in this chapter. Halogen part is taken as what? Is halogen part taken as secondary prefix, or is halogen part taken as secondary suffix? Now when you do your grade 11 organic chemistry, you people write the order of importance of the functional groups in the naming of IUPAC nomenclature, in which we know carboxylic acid is the king of the functional groups. Now when you do that, okay, you study halogens as a functional group. But though there you see halogen as a functional group, when you are doing the IUPAC nomenclature of haloalkanes, we will not take the halogen as the secondary suffix, but instead we will take halogen as substituent. So very important point in naming of haloalkanes and haloarenes, we take the halogen part as the substituent. So whenever you are taking the halogen part as a substituent, we are going to put it as your secondary prefix. So halogen should be put as your secondary prefix. Now, because when you are naming your haloalkane, okay, how will you put the IUPAC nomenclature for haloalkane? How will you write the IUPAC nomenclature of haloalkane? First you will write your halogen part. Okay, first you will write your halogen part. Okay, first you write your halogen part, and then you will write your alkane part. Okay, and then you write your alkane part. Okay, so always halogen part should be taken as your secondary prefix. Okay, if you have any other things that you can incorporate in between, that is not a big problem. Okay, halogen part, then alkane part. So before that you will write word root and all that will follow according to the format. But first, which part you should write in haloalkane? Okay, you should be writing halogen part, then only you should write the word root and which type of ane, enol and all that will follow later. If in additional you have any functional group, you can write that if needed. Okay, now if you take the halogen part, the usually commonly taken halogens are what? Fluorine, chlorine, bromine, iodine. So how should I write my fluorine as secondary prefix? My fluorine I write as fluoro, because it is halo, it will be fluoro. If bromine is your, okay, if bromine is your substituent, if bromine is your substituent halogen, then your secondary prefix should be what? Then your secondary prefix should be bromo. Okay, fluoro. Okay, we'll write chlorine. If chlorine is your substituent, then it will be written as your secondary prefix. How will I write? Halo. So it will be what? Chloro. Then if it is iodine, how will we write it? We will write it as iodo. Okay, so like this, you will take your halogen part as a secondary prefix and name like fluoro, bromo, chloro, iodo. Okay, bromo, hexane. Okay, iodo, heptane. Okay, so this is how you name your haloalkanes. Okay, whenever you are doing, whenever you are taking halogen part, be very careful. Never ever it should be taken as a functional group while naming. You should always take it as a substituent, as your secondary prefix. So we are not going into so much detailing because I have just revised this for a basic understanding, because now we are going to name many compounds under haloalkanes and haloarenes. So I just want to give you a quick briefing of the basics, so that when we do the questions now for IUPAC nomenclature, you will not have any confusion in your mind. If you have any confusions while solving questions on IUPAC nomenclature now, all your doubts will be clarified. So let us do lot of questions on the IUPAC nomenclature in this chapter. So let's start. Now let us start naming few haloalkanes. Okay, we will try to write common names wherever it is necessary. Okay, also IUPAC we will write for all the compounds. Okay, see this compound. Okay, here I have my chlorine. So chlorine group as a halogen, as a substituent, where will I take it as? I will take it as secondary prefix. So it will be chloro. Okay, one carbon. Meth will be my word root. There is no unsaturation, so I will write methane. IUPAC name will be chloromethane. What will be the common name? Methyl chloride. Okay. My secondary prefix, primary prefix not needed because it is not a cyclic compound. Then comes my word root, which is meth, which indicates the number of carbon atoms. Then comes my primary suffix, which tells about the unsaturation. It is okay. It is doesn't have any unsaturation, so I am not writing ene or ine. I don't have any functional group as such, so this is my naming. Now come to the second compound. I can either number from the left side or right side. If I am numbering from the left side, the carbon holding halogen will get number 3. But if I am numbering from the right side, the carbon holding halogen will get number 1. So I will prefer numbering from the left side. Okay, so how will I number it? 1, 2, 3. So first comes my substituent. So 1 chloro, propane. Okay, when it comes to the common naming, how will I write it as? N-propyl chloride. Okay, when it comes to common naming, I write it as N-propyl chloride because I have 3 carbons, and because it is a straight chain, I write it as N-propyl chloride. 1-chloropropane is the IUPAC naming. Common naming will be N-propyl chloride. Now let us do the next compound. Here it is, it is same if I number from left or right. So I will number from the left side. 1, 2, 3. Okay, 1, 2, 3. So at the second position, at the second carbon, I have 2 chlorine. So how will I write it as? 2,2-dichloro. Okay, I'll write it as 2,2-dichloro-propane. Okay, at second carbon, I have my 2 chlorines, 2,2-dichloro. Okay, word root is prop, and it is your propane, as there is no unsaturation. When you come to this compound, if I number from the left side, 1, 2, 3, 4. Okay, so my carbon holding halogens will get number 2 and number 3. If I number from the right side, even then the carbon holding halogens will get number 2 and number 3. As such, there is no preference here. Bromine and chlorine, both of them are halogens, so they will get an equal preference. Now, when you are getting equal preference from both the sides, I need a tiebreaker. if I need a tiebreaker, if the preference is same from both the sides regarding halogens, then what will I do? I'll go with the alphabetical order. If you take bromine and chlorine, okay, bromo, chloro, bromine is starts with alphabet B, which comes first in the alphabetical order. So I will number in such a way that where the carbon holding bromine will get a lesser number. So how will I number it? 1, 2, 3, 4. Okay, and it has 4 carbons. So I will name it 2 bromo, 3 chloro. Okay, 2 bromo, 3 chloro, butane. Okay, butane. 4 carbons, no unsaturation. So it is 2 bromo, 3 chloro, butane. Now when you come to this, if I number from the left side, I'll get this carbon will get 1, 2, 3. If I number from the right side, I'll get 1, 2, 3. Okay, either ways, okay, here what is the thing is, if I am numbering from the left side, my carbon holding double bond is getting least number. If I am numbering from the right side, the carbon holding halogen is getting the least number. But you people know in the priority order, double bond is above the halogen. So that is the reason I will number in such a way that the carbon holding double bond will get a very less number. Okay, 1, 2, okay, 3. Okay, 1, 2, 3. So at the third carbon, I have my chlorine. So what will I write it as? 3 chloro, okay, prop, 1 in, or you can just write it as propane also, it is correct because it is first position only, you need not specify it. You can write prop 1 in, or you can just write it as propene. Now let us see the sixth compound. Okay, before we will do the sixth compound after we do all the questions here. Why, I will tell you later. Okay, now come to this compound. If I number from the left side, 1, 2, 3, 4. Okay, the carbon holding a double bond will get number 2. If I am numbering from this side, the carbon holding double bond will still get number 2. If either sides I am getting number 2 only and double bond is at higher preference, okay, it is fine. For me, double bond wise, both the sides will getting same number. Now, here if you see, if I am numbering from this side, my carbon holding halogen will get number 1. If I am numbering from this side, the carbon holding halogen is getting number 4. If the double bond is getting the same number from both the sides, then why do you prefer to give such a big number to carbon holding halogen? Okay, so that is the reason preferably we will give this number 1, 1, 2, 3, 4. So the double bond is getting a good number either from both the sides, but this also will get a good number of 1 because this is a carbon holding halogen. Now how will I do this? Okay, 1 bromo. Okay, the word root is what here? 4 carbons, but 2 in. 1 bromo, but 2 in. Like this I will name it. Now when you come to the next compound, how many carbons you have in the longest chain? This will be my longest chain, 1, 2, 3, 4. Okay, now the thing is, should I number from the left side or should I number from the right side? Methyl and chlorine, both of them are substituents only, so none of them will get a higher preference. So either if I number from the left side, it is 2, 3, or if I number from right side, even then it is 2, 3 only. Then if there is a tiebreaker, what will I, if there is a tiebreaker regarding the priority of the substituents, then what will I further think about? I'll think about the alphabetical order. Here it is methyl, here it is chloro, and C comes first in the alphabetical order. So I will number now in such a way that my carbon holding chlorine will get a less number. So it is your 1, 2, 3, 4. Okay, 1, 2, 3, 4. So it will be my 2 chloro, 3 methyl. Okay, it will be my 2 chloro, 3 methyl. Okay, 2 chloro, 3 methyl. How many carbons are there in the main carbon chain? I have 4 carbons and there is no unsaturation. So this will be my butane. 2 chloro, 3 methyl butane. Why more preference to the carbon holding chlorine? According to the alphabetical order, not according to the priority of the substituent. Now let us see this compound here. Okay, now we came to a cyclic compound. So now comes our primary prefix into play. Okay, halogen, which is here, will be my secondary prefix, and then comes my primary prefix. Because it is a cyclic compound, I will add my primary prefix now as cyclo. Now when you come to the numbering, obviously the carbon holding halogen will try to give it the least number. So it is your 1, 2, 3, 4, 5. So what will be the name of this compound? 1-chloro being the primary prefix, then comes my cyclo, and then word root, and then unsaturation. So it will be 1-chloro, okay, 1-chloro, cyclo. Okay, it is your pentane ring because it has 5 carbons and no unsaturation. 1-chloro-cyclopentane. The name will be 1-chloro-cyclopentane. Okay, now let us see these two compounds and then we will go for this compound. Now when you come to these two compounds, as such IUPAC naming is not tough. Okay, that is the reason for these two compounds I will give you the job of doing the IUPAC nomenclature of this. Okay, because IUPAC, after doing this many compounds, I don't think doing IUPAC nomenclature of this will be a problem for you. So IUPAC nomenclature of this compound and this compound, you will try it by yourself. Now my major motto here is to do the common naming of this, because children usually get confused in the common naming of these compounds, and in exam they use the common names of these compounds. So let us focus on the common name of these compounds, because with the knowledge you have till now, you can easily do the IUPAC nomenclature of these three compounds. Now if you see this compound, now I will tell you a small thing. In common naming, whenever you have, okay, whenever you have carbon at an angle of 90 degrees, okay, whenever you have your carbon bond at an angle of 90 degrees to a corner, to a particular end, okay, you have to see the end of the compound to a particular end. When you have carbon at an angle of 90 degrees, then you will use the word iso. Okay, then remember this, okay, at a particular end, your carbon skeleton should be at an angle of 90 degrees. This is how you can very easily identify your iso compound. Now if you see this compound, okay, IUPAC nomenclature you people will do, okay, so I'm not worried much about it. Okay, here it will be what, okay, because I have a carbon 90 degrees bond at the end, I will write it as iso. Okay, I'll write it as iso. It is common naming. In this compound, how many carbons I have? 4 carbons. So it will be isobutyl. I have chlorine, so I will write it as chloride. So what is the name of this compound? Iso, because I have carbon at an angle of 90 degrees at a corner. Okay, so it will be my isobutyl chloride. In the same way, if you try to name this compound, I have my carbon bond at an angle of 90 degrees, okay, to a side. Now I will name it as, so this is by default, I'll write iso. Now how many carbons are there in the compound? 1, 2, 3, 4, 5. So this will be my isopentyl chloride, and IUPAC you will take care. Clear? So if this is isobutyl chloride and if this is isopentyl chloride, and I clearly told you carbon should be at an angle of 90 degrees at this place, then come to this compound now. Okay, now when you come to this compound, there is no way, according to the common naming you generally do in chemistry, there is no way you think about this compound as iso. But here it is a very important example. Here we use the word iso only for this case where the carbon chain has 3 carbons, okay, where the carbon chain has 3 carbons, and instead of taking this chlorine as secondary, okay, instead of taking this carbon as a secondary carbon and name it, here we'll do it little differently. Okay, whenever a haloalkane, remember very carefully, whenever a haloalkane has 3 carbons in its main chain, okay, though we don't have this carbon 90 degrees thing in the compound, still we call it as what? Isopropyl chloride. So kindly remember this name, isopropyl chloride. Here we name it as isopropyl chloride, though we don't have carbon bond here, we still call it as isopropyl chloride. This is isopropyl chloride, and this is only applicable when you have this 3 carbon thing and chlorine being there at the second carbon. So please remember this. Okay, whenever you get this, don't write some other name. It is isopropyl chloride only. Here we don't follow strictly that iso basic thing. For all other compounds, you can strictly follow, check for the carbon 90 degrees bond and then put iso and then write the number of carbon atoms. Only for this compound, please kindly take care. So here we have seen the IUPAC and common naming of a few important compounds. Now to get an even better understanding, we'll do few more examples. Okay, we'll do few more examples and then we'll go for the next important part, which is our isomerism. Now we'll try to write the structures from the IUPAC names. Okay, let us see the first compound, 2-chloro-3-methyl pentane. Okay, now you know pentane is 5 carbon. So it will be, how will I write it? 1, 2, 3, 4, 5. Now at the second position I have my chloro. So here I put my chlorine. At the third position I have my methyl. Okay, remaining I'll put the bonds now and fill the hydrogens. Okay, and fill the hydrogens according to the valency of the carbon. Already one bond is there. So CH3, two bonds, three bonds are already there. So CH, three bonds already there, CH, two bonds there to H2. So here it will be CH3. This will be my 2-chloro 3-methyl pentane. If you want, you can number and check. 2-chloro 3-methyl and 5 carbons in the main chain. So it will be 2-chloro 3-methyl pentane. Now if you come to the second compound, it is my cyclohexane. On that I have two substituents. So let me first write cyclohexane here. Okay, cyclohexane. Okay, and at first position I have my chlorine, and at the fourth position, so this will be my 1, 2, 3, 4, 5, 6. At the fourth position I have my ethyl group. So let me put ethyl group here. So this is my 1-chloro 4-ethyl cyclohexane. Okay, now when you come to the next compound, 4-tertiary butyl 3-iodoheptane. So till 3-iodoheptane, you people have no confusion. But here you see it is tertiary butyl. For your better understanding, I have written how do we write secondary butyl, tertiary butyl and N-butyl here. N-butyl you people easily understand. This is my tertiary butyl. Why? Because the carbon here is surrounded by 3 carbons, so it is tertiary. Okay, because it has 4 carbons, it is butyl. So it is tertiary butyl. Now when you come to secondary butyl, okay, here this is my secondary carbon. Okay, I am attaching this through the secondary carbon. I am attaching this through the secondary carbon, and this chain has 4 carbons, so it is secondary butyl. Here I am attaching through the tertiary carbon. Here I am attaching through the secondary carbon. Whenever the attachment is to tertiary carbon, I wrote it as tertiary butyl. Whenever the attachment is through secondary carbon, I have written it as secondary butyl. Okay, now let me write it accordingly now. Okay, heptane, if it is heptane, how many carbons I should have? I should be having 7. 1, 2, 3, 4, 5, 6, 7. Okay, 7 carbons. Now let me put the substituents. Okay, at the third carbon I should have iodo. Okay, so I'll keep iodo here. At the fourth carbon I should be having my tertiary butyl. So I will keep my tertiary butyl group over here. Okay, so I will just attach it so that it is easy for you. Okay, let me attach like this. Okay, CH3. Okay, this is my tertiary butyl. I have attached the tertiary butyl group over here. Remaining is we are done with the substituents. Now let us put a carbon-carbon bonds and put the hydrogens also. CH3, CH2, CH2. Here carbon already 3 bonds are filled. So CH, here CH. Here it is CH2 and here it is my CH3. So you can check it now. Okay, 1, 2, 3, 4, 5, 6, 7. So what it will be? It will be my 4 tertiary butyl, 3 iodoheptane. Now if you are thinking in the naming, why did they write tertiary butyl first and then iodo? It is according to the alphabetical order. Please don't write it as 3 iodo 4 tertiary butyl heptane. That is wrong. You people have studied in grade 1, but I am still reminding you once again. So whenever you are putting this substituent, always the substituent should be put according to the alphabetical order. So though the number 3 comes first, but we will not write 3 iodo first. We will write 4 tertiary butyl, then 3 iodo. Why? Because in the alphabetical order, B comes first and then comes my I. You will not consider this T when you are checking the alphabetical order. You will check the first letter of butyl, which is B, which comes before I in the alphabetical order. So this is my 4 tertiary butyl, 3 iodoheptane. Now see the next compound, 1,4-dibromo-butene. So it is my bute, so it will be my 4 carbons, 1, 2, 3, 4. Okay, then 1,4-dibromo. So I can number from here or here, it doesn't make a difference because I am putting it at first and fourth position. So here it will be my bromine, here it will be my bromine. So 1,4, okay, dibromo, okay, 1, 2, 3, 4. 1,4-dibromo butene. So my double bond should come at second position. You can number from either side, so it is same only. my double bond will come at second position. So it is 1,4-dibromo-but2e. Remaining, you people know how to fill it now. Okay, CH2, here it will be CH, here it will be CH, and it is my CH2Br. Okay, this is my 1,4, okay, 1,4-dibromo-but2e. Now let us do the last one. Here I have written neopentyl chloride as a homework question. Neopentyl, think you people already studied in grade 11, that is the reason with that confidence expecting neopentyl chloride. See, all these are IUPAC names. This is not an IUPAC name. This is my common name. Okay, I want you to write the structure of neopentyl chloride. You people try by yourself. If you are not getting it, I'll tell you in the next session. Okay, 1-bromo, 4-secondary butyl, 2-methyl benzene. Very long name, but it is simple. Okay, we will not get worried by looking at the magnitude of the question. Okay, 1-bromo, 4-secondary butyl, 2-methyl benzene. So it's a benzene ring. So first let me write benzene ring here. Okay, first let me write benzene ring. Okay, I have written my benzene ring here. Okay, 1-bromo, 4-secondary butyl, 2-methyl. See how neatly they have written according to the alphabetical order. Okay, bromine, okay, butyl, methyl. Okay, bromine, butyl and methyl. So please check the alphabetical order when you are naming, because it is already named and given. We are just writing the structure out of it. 1-bromo, so here I will take it as first carbon. 1, 2, 3, 4, 5, 6. Okay, it will be what? 1-bromo, 4-secondary butyl, 2-methyl benzene. So I'll first write 2-methyl here, because after one I have 2 here. Okay. 1-bromo, 2-methyl. Now let me put 4-secondary butyl. How to write secondary butyl I have already shown you, because I am attaching it through the secondary carbon. I have written as secondary butyl. So here I will write my secondary butyl. CH, this side I will get my CH3, this side I will get my CH3. This is my butyl group attached through a secondary carbon. So this is my secondary butyl. So the name is 1-bromo, 2-methyl, 4-secondary butyl. Okay. These are my substituent. Now go according to the alphabetical order. 1-bromo, okay, then your 4-secondary butyl, then your 2-methyl, then comes your benzene. Okay, so this is how you name your organic compounds. Okay, by using the basic rules of IUPAC nomenclature. I have taken only those compounds which are useful for us for this chapter, because we are doing the chapter Haloalkanes and Haloarenes. So how much is useful for this chapter? I am trying to put all those things so that you should not have any sort of confusion when we go to the preparation of properties of these compounds in the chapter. So have a lot of clarity on the naming of the compounds. So this is just a brief thing on the IUPAC nomenclature of haloalkanes and haloarenes. So hope IUPAC nomenclature is almost clear for you. Please keep trying more questions. If you have any doubt, you can put it in the comment section. I will try to clarify in the next session. Now let's try to do a very important topic, which is my isomerism. Okay, haloalkanes show which kind of isomerism, chain position, or which kind of isomerism they show. Let us see now. Hope this is clear for you. Let us see isomerism here. Isomerism as such is not a grade 12 concept, but because we are doing haloalkanes and we know haloalkanes show isomerism, we need to little bit at least briefly understand like what kinds of isomerism do they show. Okay, to understand that I have taken a very simple compound. Okay, and I will try to write the all possible isomers of this. Okay, now if I go with C4H9Br, okay, haloalkanes as such will definitely show chain isomerism. You people know there are different kinds of isomerism. So here it can show chain isomerism. So whenever you talk about haloalkanes can show chain isomerism. So you people know what is chain isomerism? Yes. What is isomerism? What is isomerism? Compounds having same molecular formula but different structural arrangement. Here I am basically talking about the structural isomerism. So compounds having same molecular formula but different structural arrangement. So molecules should have molecular formula C4H9Br and they should have different structural arrangement. Now when I talk about chain isomerism, I will be writing chain isomers for this compound. What is the basic thing you should know for chain isomerism? In chain isomerism, the main carbon chain which you choose for the numbering, okay, should never be same. Means what? Let us try to understand. How can I write C4H9Br, CH3, CH2, CH2, CH2Br. This is my one isomer, one chain isomer. Okay, let me write here. Okay, I am writing which type of isomers here. I am writing chain isomers. I am writing chain isomer. So this is one chain. This is one chain isomer. Now, if I want to write the other isomer of this, other isomer is possible. Why? Because okay, now in the main chain, how many carbons I have? Okay, let me name it first. Okay, I will number from this side 1, 2, 3, 4. Because if I number from this side, this all I already taught you previously when we did so many examples. If I number from here, carbon holding bromine will get a lesser number. So what will be the name here? 1 bromo butane. Okay, this is the name. Now when we are writing the other chain isomer for this compound, the main carbon chain should not have 4 carbons. If the main chain again has 4 carbons, then you don't consider it as chain isomer, because your main chain length should be different. Now here the main chain length is 4 carbon. Now here I will take my main chain length has 3 carbons. Then it will be CH3, CH, CH2, Br, and I will put my other carbon here. Okay, I'll put my other carbon here. See here the main chain has 4 carbons. Here my main chain has 3 carbons. If you want, you can number it. I'll prefer numbering from which side? I'll prefer numbering from the right side. Why? Because if I number from the left side, this carbon will get number 2, this carbon will get number 3. Okay, either it's methyl and bromine, both are substituents only. I told you in terms of substituents, when there is a tie, I will go with the alphabetical order. Okay, now in that case, if I number from here, I will get carbon holding bromine. Okay, it will get a lesser number. So here it will be my 1, 2, 3. Okay, 1, 2, 3. So what will be the naming here? 1 bromo 2 methyl propane. What will be the naming here? 1 bromo 2 methyl propane. 1 bromo 2 methyl propane. Okay, so here my main carbon chain has 4 carbons. Here my main carbon chain has 3 carbons. So in chain isomerism, you have to deal with the carbon chain. Okay, you have to deal with the carbon chain. Now if you are thinking, ma'am, why don't you write with 2 carbons? How can I write with 2 carbons? If I write with 2 carbons, I will write my 2 carbons like this. Okay, one more carbon I have to put here. Okay, okay, one more carbon, where will I put here? Here. Doesn't make any sense, no? Can I write it? Okay, can I write with 2 carbons? I can't write, because you people already know how many minimum carbons should I need to have in the main chain to write isomers. At least 3. Okay, at least 3. In the main chain, if I have at least 3 carbons, only I can think of writing isomers. Okay, people have seen in your grade 10, right? In your grade 10, there has been a very clear statement. If you see the carbon and its compounds chapter, to show isomerism, the minimum number of carbons should be 4. Okay, now here the minimum number of carbons is 4. That is the reason it is showing my chain isomerism. But I can't write a structure where my main chain has only 2 carbons, because my other 2 carbons will obviously come. One carbon will come onto this, or one carbon will come onto this, or both the carbons will come to one side. So again it will be either of these structures only. So there is no point taking 2 carbons in the main chain. If you want, you can try writing it. Take 2 carbons here. Either I will put 1 carbon here, 1 carbon here, and then I'll put my bromine here. Okay, and then I'll put my bromine here. Is it not the same structure like this? If you start numbering it according to the basics of IUPAC nomenclature, you will again get the same structure. Or if you are thinking, I'll put my 2 carbons like this, and I'll put my 2 carbons to this, then again it is the same structure as this. Okay, so there is no point taking 2 carbons in the main chain. Okay, so I get how many chain isomers here? I get 2 chain isomers. Always take care, in chain isomers, you should see that your main carbon chain should be different in both the isomers. If you are again getting 4 carbons in the main chain here, it is wrong. So please check the number of carbons present in the main chain should be different. In C4H9Br, I can get 2 chain isomers like this. Now let me write their position isomers. Now when I am writing the position isomers, I will not deal with the carbon length, chain length. I will deal with the position of my bromine, because bromine is my main substituent here. Okay, or else you can take it as a functional group according to your grade 11 priority order which you have. Now I have to deal not with the chain length of the carbons, but I have to deal with the position of bromine here. Okay, so the carbon chain length should be same for the main chain, but the bromine position should be different whenever I am writing my position isomers. Because I have bromine here, I can write my position isomers. So my first one will be the straight chain one, CH3, CH2, 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 Br. Okay, CH2Br. So you can number it 1, 2, 3, 4. Now I should keep my carbon chain length same, which is my 4 carbons, and just change the position of my bromine. Here bromine is there on the first carbon. Now I can keep my bromine on my second carbon. So it will be CH3, CH2, CH, CH3Br. I am numbering from here because my bromine carbon holding bromine will get a lesser number. So 1, 2, 3, 4. Okay. Now don't be smart that don't put your okay, don't put it on this carbon and then say 3 bromobutane. No. If you are putting bromine here, then obviously you will number from here. Then it will become 2 bromo. It will be the same structure. Okay. So I have 2 structures possible. Okay. So what is this structure? The same one as before. You can name it as 1 bromobutane. Here how will you name it? Okay, you will name it as 2 bromobutane. Now if you see, your word root will remain the same because you are not dealing with carbon chain length. Carbon chain length you will keep it as same. You will only change the position of your bromine. Here the bromine is on the first carbon. Here I am keeping my bromine on the second carbon. You can do it from this side also. You can put bromine onto this carbon if you don't want on this carbon. Then number from the left side. Then this will be 1 bromobutane. Then you can keep your carbon here, then it will be your 2 bromobutane. See, numbering from left or right is your choice. Okay, only see that carbon holding bromine should get a lesser number. Okay, keep that in mind. And these two will be the position isomers. How to identify chain and position? Very easily. In chain isomers, the carbon chain, main chain length will be different in both the isomers. In positional isomers, the carbon chain length will remain same in both the compounds, but the position of the substituent or the functional group will be different. Okay, so this is how I write the chain and position isomers. And when you come to the functional isomerism, they don't show functional isomerism, group isomerism, because we are not taking chlorine, bromine, iodine or fluorine as functional groups as such. Here we are just taking them as substituents. That is the reason they don't show any functional group isomerism. There is no point of showing metamerism because you know where do metamerism takes place. Now we are not going into the stereoisomerism part here. We are only dealing with the structural isomerism, where they can show both your chain and positional isomerism, but they cannot show your functional group isomerism or your metamerism. Now, to understand it in a very better way, to understand how to write the isomers in a very better way, you have a very important question in NCERT, okay, where you need to write 8 structural isomers for a particular compound. Let us see that if you can do that question, then your understanding of isomerism will improve very much. So let us do that question. Let us see this very important question for isomerism of haloalkanes. Draw the structures of all the 8 structural isomers that have the molecular formula C5H11Br. Name each isomer according to the IUPAC system and classify them into primary, secondary or tertiary bromide. Let us do this question now. Okay, my compound is C5H11Br. Okay, he already told we should write 8 isomers, so that makes our job more easy. First is CH3, CH2, 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 CH2Br. Okay, this is my straight chain compound. Okay, what will be the name for this? Now I'm not again writing 1, 2, 3, 4 and doing the things because we have enough practice of this now. Okay, now can I write directly the IUPAC name for this? 1 bromo. This will be my first carbon because my least purity will be given, least number will be given to this carbon. 1 bromo pentane because it has 5 carbons. Now first let us finish the positional isomer thing. The bromine is on the first carbon. I can write one more structure keeping bromine on this carbon. I can write one more structure keeping bromine on this carbon. So I'll get 2 structures like that. Let us do it. CH3, CH2, CH2, CH, CH3Br. Here bromine was on the first carbon. Here I am keeping bromine on the second carbon. Now the name will be what? 2 bromo pentane. The main carbon chain remains same. Now I can keep the bromine on the third carbon. third carbon. Write the structure. CH3, CH2, CH, CH. Sorry, I should write my Br. Okay, Br, CH2, CH3. Here my bromine is on the third carbon. So what will be the name here? 3-bromo-pentane. So I got my 3 structures by just changing the position of the bromine atom in the given structure. Now what can I? Okay, this is my 5 carbon chain. So I can make it a 4 carbon in the main chain. From 5 carbon being in the main chain, I can make it into 4 carbon in the main chain. So how will I write it? I already got 3. So let us try 5 more now. Okay, CH3, CH2, CH2, CH, okay, Br. Let me put CH3 here. Okay, I am keeping how many carbons in the main chain now here? 4 carbons. And I put methyl on this carbon. And I put methyl on this carbon. Okay, now how will I write the name of the structure? 1-bromo-2-methyl-butane. 1-bromo-2-methyl-butane. Because I'll preferably number from this side, so that because if I number from this side, carbon holding bromine will get number 1. So 1-bromo, because bromine comes first in the alphabetical order, I am writing 1-bromo 2-methyl-butane. Just see that the names don't repeat anywhere, because the name is repeating, you are again writing the same structure, which you should not be doing. Okay, 1-bromo 2-methyl-butane. Let us try one more possibility. Okay, let us try one more possibility. Can I keep the methyl on this carbon and try one more structure? Keeping 4 carbons in the main chain. CH3, CH, CH3, CH2, CH, Br. What is the change I made here? Instead of putting my methyl on the second carbon, I am putting my methyl on the third carbon, because I will number from this side, because carbon holding bromine is here. If I number from this side, now this carbon got number 2 here. Now this carbon will get number 3. So what will be my name here? Still it will be 1-bromo, 3-methyl-butane. If the name is different, then you are successful. See the number of hydrogens also. If you want, check the number of hydrogens for all the compounds, it will remain the same as long as you are satisfying the valency of the carbon. Here it is 1-bromo 2-methyl-butane. Here it is 1-bromo 3-methyl-butane. Okay, I got 2 structures keeping 4 carbons in the main chain. Can I get one more structure keeping the carbons in the main chain? Can I? Yes, I can. Okay, how can I get it now? Please see here. Okay, I will keep this as CH3 and bring the Br here. Let us see now. I'll do like this: CH3, CH, CH3, CH, Br, CH3. I am keeping only carbons in the main chain, and I am bringing bromine as substituent on the second carbon. Okay, and I am bringing. Did I write the structure before? No, I didn't write, so I can go with this structure. Okay, I have written. Okay, I didn't write the structure before, and the structure is absolutely right. And the structure is absolutely right. I have taken bromine on the bromine as a substituent and methyl as a substituent on the second and the third carbons. Now, if you are trying to number it here, preferably I will number from the right hand side, because methyl and bromine both are substituents. So in that case, both will get equal priority. But I told you, when it is a tie, you have to go on the basis of the alphabetical order. If I am numbering from this side, my carbon holding bromine will get number 2. So here it will be 1, 2, 3, 4. So what will be the name here? 2-bromo 3-methyl-butane. Okay, 2-bromo 3-methyl-butane. Okay, with 4 carbons in the main chain, I have tried 3 possibilities. Can I get any more possibility with 4 carbons being in the main chain? Now we are getting closer. We already wrote 6 structures, so we have to now get only 2 structures. Now 4 carbons being in the main chain, can I get one more structure? I can get. See here I have put methyl and bromine on 2 different carbons. What if I put methyl and bromine on the same carbon? I can do it. CH3, Br. Now this will be my CH3, CH2. Here the valency is already satisfied. CH. Look at this structure. Did we write it before? No. I have put 4 carbons in the main chain, and I have taken methyl and bromine on different carbons in the previous compound. Now I'll take them on the same compound in this compound. Now try to number it. I'll preferably number from this side only so that my carbon holding bromine and methyl will get a less number. So 1, 2, 3, 4. 1, 2, 3, 4. Now here is it 2. Okay. Now I have my methyl and bromine both on the second carbon. So how will I write it? Write it as, okay, 2 bromo, 2 methyl. Why am I writing bromine first? According to the alphabetical order. 2 bromo, 2 methyl butane. 2 bromo, 2 methyl butane. Did I get this name before? No. Here I got 2 bromo, 3 methyl butane. Here I am getting 2 bromo, 2 methyl butane. Okay, so my 7 structures are done. Now with 4 carbons in the main chain, I can't get any other possibility because I tried putting bromine here. Already that possibility is done. I tried putting bromine and methyl on different carbons. That possibility is done. I did put, okay, methyl and bromine on the same carbon. That combination is done. Now with 4 carbons in the main chain, I don't think we have any other possibility. With 5 carbons in the main chain, I already wrote the positional isomers. Now I can try 3 carbons being in the main chain. Okay, 3 carbons being in the main chain. Now, what else is pending for me? What else is pending? I already have 3 carbons in the main chain. So I have 2 more carbons. So I can put 1 carbon here, 1 carbon here, and I can write it as CH2Br. Here it will be CH3, CH3, CH3. Yes, this I can write. Okay, you now if you know, now you can check. You can put Br here or you can put Br here. The structure will be the same. Okay, the structure will be the same. Okay, you try anywhere, you put Br here, the structure will be the same. So with 3 carbons being in the main chain, this is the only possibility. Okay, only possibility I get here. Okay, if you want, you can check. If you put here CH2Br here and CH3 here, either way my main chain will be this. So if Br you put on any carbon here, Br you put on any one of the 4 carbons here, the structure will be same. So there is only one possibility I can get for three carbons being in the main chain, and that structure is this. Now let me do the IUPAC nomenclature of this. Okay, this will be my main chain, because in this, if I take this as a main chain, I will get carbon having bromine in the main chain, which I would prefer. Okay, so 1, 2, 3. Okay, 1, 2, 3. So how will I write the name here? As 2,2 dimethyl. Okay, 2,2 dimethyl. Okay, should I write 1 bromo before here? Yes, I should write 1 bromo before, so I should not miss that. Okay, 1 bromo. Okay, why is the bromo coming at the starting here? Because here it is M, here it is B, so my 1 bromo should come first. So it will be 1 bromo, 2,2 dimethyl. How many carbons I have in the main chain? 3. So it will be my, okay, 1 bromo, 2,2 dimethyl propane is the name. Okay, how many structures I got? 1, 2, 3, 4, 5, 6, 7, 8. And what did he say in the question? I should write all the 8 structural isomers that have the molecular formula C5H11Br and name each isomer according to the IUPAC system. I have named everything according to the IUPAC system and classify them as primary, secondary and tertiary bromide. Now let me classify them as primary, secondary and tertiary bromide. Now here bromine is attached to primary, the bromine is attached to primary carbon. So this is my primary bromide. Here bromine is attached to secondary carbon. So this is my secondary bromide. Here my bromine is attached to secondary carbon. So this is my secondary bromide. So here my bromine is attached to a primary carbon. So this will be my primary bromide. Okay, here my bromine is attached to the, okay, here I have to put one more hydrogen, sorry. Okay, here the bromine is attached to primary carbon. So this is my primary bromide. Here bromine is attached to secondary carbon. So this will be secondary bromide. Here bromine is attached to a tertiary carbon. Am I right? Okay, here bromine is attached to a tertiary carbon. So this will be my tertiary bromide. Here the bromine is attached to a primary carbon. So this will be my primary bromide. Once check primary bromide, bromine to secondary, secondary bromide, bromine to secondary, secondary bromide, bromine to primary, primary bromide, bromine to primary, primary bromide, bromine to secondary, secondary bromide, bromine to tertiary, tertiary bromide, and bromine to primary is your primary bromide. So we have done all those they have asked. This is a very important question, and this question will give you an in-depth understanding of your isomerism and how to write the structural isomerism, structural isomers of your haloalkanes. I hope this concept is clear for you. Isomerism is not a new concept as such. It was there in grade 11, so I'm just trying to put the things which are important for this chapter here. Okay, so hope you understood today's session very well. I tried to do in detail all the IUPAC nomenclature part and the isomerism part needed for this chapter. Okay, with lot of questions. I have taken lot of questions so that your understanding is clear. When you try and attempt a question in the exam, you shouldn't falter there. Okay, that is the reason I tried doing enough number of questions. I thought of doing nature of CX bond 2 in today's session, but I think it is going very longer and you will be tired watching very longer sessions. That is the reason I'll make a very short video only on nature of the CX bond, because that next video I want to do methods of preparation of haloalkanes exclusively. So in the next session, I'll take a very short session on the nature of CX bond, which is very important and questions repeatedly come from that particular topic. Okay, hope you understood the session. Okay, so keep watching my channel. See you in the next session. Till then, take care.